Section 12.4b is about dimensional analysis. We've talked about this in the past. Dimensional analysis is taking the units and including them in a problem and then canceling the units in a controlled way to get an output that you want. In this example, we talk about that it took a global surveyor 309 days for the orbiter to travel that many miles, 466 million miles. But we want to know the speed of the spacecraft in miles per hour. So we're given a value of days. We want to convert that to hours. Well, this is a distance equals rate times time problem. So let's start by putting the values in that we know, and we're going to include the units so that we can then cancel them out and get it to finally give us an answer in miles per hour. So the distance we're told is 466 million miles, and notice I kept the miles in there. We don't know the speed or the rate, but we know that it took 309 days. To solve for the r, we're going to divide both sides by 309 days. So now I'm going to rewrite the problem. So here's the actual problem. When we could figure out the speed by dividing this top number by this bottom number, but that would give us an answer that's in miles per day. We want our answer to be in miles per hour. So we've got to convert days to hours. So we're going to multiply by some fraction that will convert days to hours. So we want to put 1 day on the top because that's going to cancel with the day on the bottom. And how many hours are in a day? Well, 24 hours. So now we can cancel day and day, and we're left with a solution then that will be in miles per hour. So now we'll take these values and we'll plug them into a calculator. So when I do that, I get 62,837.11. And now how should we label it? We should label it miles per hour, which is exactly what I wanted to find. Here's a dimensional analysis problem about making candy in a 2-quart pan. Stirring in the mixture and noticing the pan is 2/3 of the way full. Each piece of candy has a volume of 3/4 of an ounce, and we want to know how many pieces. So we've got to go from a 2-quart pan, we've got to convert that to ounces so that we can figure out how many ounces go into our mixture, and then convert that to pieces of candy. So let's get started. We'll start with 2-quart pan over 1 because that's just the beginning value. And we're told that pan is only 2/3 full, so we have to multiply by 2/3 because we don't have a full pan. Now we've got to convert the quarts into ounces so that we can divide and find out how many pieces are in there. Well, you can Google and find that there are 32 ounces in 1 quart. So that's going to successfully cancel the quarts, leaving me with ounces. Now I've got to get ounces to be in pieces of candy. Well, we're told that each piece has a volume of 3/4, so if I take the amount of ounces and divide it by 3/4, that'll tell me how many pieces I have. So I can say that 1 piece of candy is 0.75 ounces, because if you divide the ounces of the pieces of candy, that will tell you how many pieces you have. So let's see what that does. Quart will cancel with quarts. Ounces will cancel with ounces. I'm left with a piece, and then I can multiply all these values. So all the numbers on top become 128. 3 times 0.75 is 2.25. And when you divide, you get about 57. And that'll be 57 pieces of candy. Here's an example that you can pause and try for yourself and see if you have this figured out. We want to convert 85 kilometers per hour into meters per second. So we start with 85 kilometers for 1 hour, and we got to convert kilometers to meters. So we want kilometers on the bottom, and how many meters in a kilometer? 1,000. So that will convert the meters for us. Now we need to convert an hour into seconds. I find it easiest to do 1 hour is 60 minutes. Because that helps me understand it a little bit better. And now I got to convert minutes to seconds, so I'll put the minutes on top, and there are 60 seconds in a minute. So we'll cancel kilometers cancel hours, minutes. So whatever I get here, I'm going to get a meter over a second, which is meters per second. So the top looks like 85,000. The bottom looks like 3,600. And then we're going to have a meter over a second. Type that into a calculator, you're going to get 23.61 meters per second. Here's an example with an interesting twist. We have to express 32 pounds per square foot as pounds per square inch. So we'll start with 32 pounds is 1 square foot, which means that's feet squared. So there's actually 2 feet units we have to cancel. So we can't just say that 1 foot is 12 inches. That will cancel one of the feet units, but we also have to do it again to cancel both of the feet units. So we've got to include 2 fractions here, because feet squared needs a foot and a foot together to cancel it out. So here we're going to have 32 over 144. You could reduce that fraction. Each one of those has a 16 in it, so you could reduce that to 2 over 9, and that would be pounds per square inch, because there's inch and inch. So that would be an acceptable answer. Also 0.2 repeating pounds per square inch is acceptable.